Question 5. The atomic number of magnesium is 12. Magnesium exists in 3 isotopes, magnesium 24, magnesium 25 and magnesium 26. Describe, by referring to the numbers of subatomic particles, the differences between one atom of each of these isotopes. So describe by referring to the numbers of subatomic particles. So when they're talking about subatomic particles, what they're asking me to talk about are protons, neutrons and electrons. Although in this instance, I'm not going to talk about electrons because it's only protons and neutrons that I need to talk about. So describe the differences between these isotopes. So magnesium 24, magnesium 25 and magnesium 26. So the number 24, 25, 26 tells me the mass of those particles or those atoms. And so magnesium has got this magnesium 24, has got a mass of 24. I know that 12 is protons because the atomic number is 12. So that tells me there are 12 protons, which means there are 12 neutrons in this atom. Magnesium 25 is also magnesium, so it also has an atomic number of 12, so it has 12 protons, but here it's slightly heavier, so it must have 13 neutrons, because 12 plus 13 is 25. And then magnesium 26 again has 12 protons because it is magnesium, which means that it has 14 neutrons because 14 plus 12 makes 26. So what I need to say to get my 2 points here are that magnesium 24 has 12 neutrons, magnesium 25 has 13 neutrons, magnesium 26 has 14 neutrons. So magnesium 25 has 1 more neutron than magnesium 24, and magnesium 26 has 2 more neutrons than magnesium 24. Okay, question B. So this is my 6-mark question, so I need to make sure that I get at least 6 points down. So a sample of magnesium contains 79% of magnesium 24, 10% of magnesium 25 and 11% of magnesium 26. In most calculations, the relative atomic mass of magnesium used is 24. Use this information to explain why in this sample magnesium has a relative atomic mass of 24.3. So here what I'm doing, remember, is that I'm not just got a sample with the 24 atom. I have 25 and 26 as well, so they're slightly heavier, so they will cause my average to become slightly more, hence the 24.3. Okay, so how am I going to write this as an answer? So I'm going to start off by saying that here I have more than one isotope. Okay, so when I'm calculating it, I have calculates a weighted mean, because my mean, my average, is weighted mainly towards the 79%. And actually, because I have most, i.e. 79%, is magnesium 24, my relative atomic mass is closer to 24 than 25 or 26. Okay, so how could I calculate this? I could show this in a calculation. Okay, so I could say 79% times 24 plus 10% times 25 plus 11% times 26. If I added those up, so 79% of 24, do that in your calculator, comes out at 18.96. 10% of 25 is 2.5. 11% of 26 is 2.86. And if I add those up, I make the answer that they've given me of 24.3. Okay, final question then. Question part C. In 1871, the Russian chemist Dmitry Mendeleev produced the first version of the periodic table. Describe how Mendeleev arranged the elements, in this first version of the periodic table. Okay, so describe how Mendeleev arranged the elements in the first version of the periodic table and why the elements are arranged differently in the modern periodic table. Okay, so I've got two parts to this question. So the first part, how did Mendeleev arrange them? He arranged them by their properties. And what he did was he then left gaps for ones that hadn't been discovered. And he ordered them in increasing atomic mass, or he thought he did, although that wasn't always true because of some isotopes that were around. So he thought that he ordered them increasing atomic mass. And in terms of modern day, they're actually ordered in increasing atomic number.